Rationalizing denominators with complex numbers. We can't have a I in the denominator, just like we can't have a 0 in the denominator, we can't have a radical in the denominator, we can't have I in the denominator either. So we use the property that we know that I squared is a -1, and so if we have an I down there, we could just multiply it by I, top and bottom of course, and it'll become 5I over 2I squared, which we know is -2 because I squared is -1. When your denominator is a polynomial or a binomial like 2 plus 3i, we can't just multiply by I because then we'll end up through distribution still having an I. So we have to do our conjugate just like we did with radicals, that we have to multiply by the conjugate of 2 plus 3i is 2 minus 3i. And we do that top and bottom. Distribute up top, we'll get 12 minus 18i. On the bottom, remember, because it's a conjugate, I know I could just do multiply my first, put a minus sign, multiply the last, 9i squared. But we know -9i squared is really +9, so I end up adding in this case. And so my answer is going to be 12 minus 18i over 4 plus 9 is 13. And I would look to see if 12, 18, and 3 can be reduced, but they can't in this case. Last one, the conjugate is 1 plus 5i. Top and bottom. Top will get -4 minus 20i. On the bottom, we just multiply the first. 1 times 1 is 1. Minus, multiply the last. We get 25i squared, but we know that becomes plus 25, and so we have -4 minus 20i over 26, and we see that our three numbers can all be divisible by 2, and so we'll get -2 minus 10i over 13.